Welcome to my channel once again. In today's topic, we are going to continue with our previous lesson. We treated quantitative analysis. We said quantitative analysis is the measurement of amount. So in today's topic now, I'm using this question as an exam focus for chemistry practical 3 that is coming up by next week, 28th of May 2025. So in this now, I'm using this question as a form of exam focus. This question is WASSCE question in 1998. So I'm going to look at this question and solve accordingly. So the question goes this way. If A, this is A, is an acid, A is 0.050 mole per dm cube ACl, and B is 0.025 mole per dm cube of triazocarbonate 4 salt. Triazocarbonate 4 salt. Calculate 1. The mole ratio of acid to triazocarbonate 4 in the reaction. We said the question to go this way. Given that B contains 7.2 grams of the hydrated triazocarbonate 4, calculate 1 as well, concentration of anhydrous salt in B. We're going to solve the mass concentration in gram per dm cube. So the molar mass of anhydrous salt is given to us to be 106 grams per mole. 2, said we should calculate the percentage of water of crystallization in the hydrated salt. So if we shall look at this question, hydrated salt is always mentioned hydrated. When we treated acid, base, and salt, we said some salt can absorb moisture from the environment, and when salts absorb moisture from the environment, they become hydrated. They contain water of crystallization. So an anhydrous salt, in a simple way, that it does not contain this water of crystallization. So we can say this is contain water, this no water. So as I've said before, that we have two important equations in quantitative analysis. If the concentration of the acid and that of the base is given to us, we have a specific formula we can use. If neither of the concentration in mole per dm cube of the acid or that of the base is not given to us, we can as well derive the concentration by using the mass conc equals to molarity times molar mass. So in this aspect, we're going to get each of these parameters that is given to us. So we take it to the side, one side of the board, so that we can have enough space to write. So we said A have a concentration of 0.050 mole per dm cube. We said B is a triazocarbonate 4 salt, so 0.025 mole per dm cube as well. This is triazocarbonate 4. This triazocarbonate carbonate 4 salt. We have here we have ACl. So in this regard, if we are asked to calculate the mole ratio of acid to triazocarbonate 4 in the reaction, you can notice that we have ACl, but the metal aspect of this triazocarbonate 4 is withheld. So we cannot actually know the formation of the product using this just using this analogy, because the metallic part of this triazocarbonate 4 has been withheld. This carbonate 4 can be sodium. It can be sodium triazocarbonate 4. It can be potassium triazocarbonate 4. It can be sodium, hydrogen triazocarbonate, any of the carbonate family. So this metallic aspect of it is withheld. So it is not possible for us to have the product automatically using this equation. That is why we are asked to look for the mole ratio of the acid to triazocarbonate 4. So we can use two methods to solve this problem. If peradventure, as a student, you cannot actually manipulate this to have this product because the metallic element is not present in the carbonate family. So we are going to solve now. So now this is given to us. Let's solve for the triazocarbonate, the mole ratio of the acid to that of the base. Let's talk about solution. So we can use, since the concentration is given to us, we can say Ca Ba all over Cb Vb equals to Na all over MB. So the CA, the concentration of the acid, the volume of the acid, CB, the concentration of the base, V is the volume of the base. So here now, let's take CA that is given to us to be 0.050, which is the concentration of the acid. So let's leave the unit so that we'll have enough space to write. This is VA. This VA is the total volume of acid used as your titer value. That means if you're having your table, your titration table I've treated before now, this three value, the first, second, and third value in your titration table, if you should sum this 3 divided by 3, you will have your titer value. As I've said before, if two values close, very, very close, you can use the 2 value divided by 2. Just sum the 2 and divide by 2. So in this aspect, this titer value is peculiar to a student. So if, for instance, now your titer value here is 23.10, for instance, and in your calculation, you say your titer value here is 24.00. That means you don't actually know what you are doing. So the examiner can infer that you copied from your friend. That is, this VA must correspond to your titer value you got in your table. So be very, very careful. So we said the CB as well is giving us 0. Which is the concentration of the base, 0.025. We said VB is the pipette, is the volume of the pipette you use, as far that it's written boldly, as I've said, it's written boldly at the top of your table. So it's 25. We are using, in this case, we are using 25 centimeter cube, for instance. So let's just remove the unit at the end. We can actually place our unit. So the NA is not given to us. The NB is not given to us. So with this now, we can actually look for this. Let's wipe this so that we'll have the equation properly. So we have CA is giving us 0.050 times let's use 23. Let's use the volume of acid to be 20. Let's be specific. 23.20. Let's use 20. So that times 23.20 all over 0.025 times 25 is equals to the mole ratio. Mole ratio of the acid and that of the base. So we are going to use, let's have this. It says 0.050 times 23.20. We have 1.16 all over 0.025 times 25. We have 0.625 is equals to, if we should divide this now, we're going to have 1.16 divided by 0.625. Here we have 1.9 mole. This now, it can be approximated to 2 mole of acid to what? To the triazocarbonate. So that is to say, this is the mole ratio. This is the mole. We can infer that this is the mole ratio of the base. This is the mole ratio of the acid. We are asked to look for the mole ratio of this acid to base. So when we divide, we go 1.98. That probably 2 mole. That is to say, if peradventure we have the mole ratio of the base, we can say 0.625 all over 0.625. We are going to have 1 ratio. So that is to say, the mole ratio of acid to base in the equation is 2:1. The mole ratio of the acid is 2, the mole ratio of the base is 2. That is to say, we can use this to calculate theoretically, checking out the mole ratio of the acid and to the base. If whenever we are asked to have a balanced equation with any of the carbonate family, let's say we have ACl plus sodium triiodocarbonate, we can infer we can have sodium chloride plus H2SO4 plus H2O and carbon dioxide. From this now, we can actually have that. In this now, we have sodium here. We should have chlorine here. We're going to have 2 mole of this. So 2 mole of this to this is as well, from the equation, we can actually infer that it's 2:1. 2:1. It's a very simple way, but you cannot have this equation automatically without knowing this metallic element that is found in the triiodocarbonate 4 family. So that is where you are asked theoretically to solve for the mole ratio of the acid to that of the base. So in this now, we know that now we have 2 mole of the acid to triiodocarbonate 4. So the mole ratio of the base, we are going to divide this mole this 0.625 by each other to have 1. So the mole ratio to one of them is what? Is 2:1. So we are going to use another method so that we can know more about this. So the other question goes this way. Given that B contains 7.2 grams per dm cube of the hydrated triiodocarbonate 4, calculate the concentration of anhydrous salt in B, that is the base, in gram per dm cube. By doing that, let's use this space. We already know that the concentration of this base is given as 0.025 of this base, of this triiodocarbonate 4. That is to say, if we should have we should look for the mass conc. That is to say, is that given that B contains, this is the mass concentration of the hydrated salt. So I'm going to solve for the mass concentration of the hydrous salt using the molar mass of the hydrous salt to be what? 106. We say mass conc in gram per dm cube of an anhydrous salt. Anhydrous salt is equals to molarity times molar mass. Molar mass of the anhydrous. The molarity of the carbonate family is 0.025 times, what is the molar mass of the anhydrous that is given is 106. 106. Here we are going to have 0.025 times 106. So now we have the mass conc. Mass conc is given as 2.65 gram per dm cube. So in this now, we now have the mass concentration of the anhydrous salt and the mass concentration of the what? Of the hydrated salt. So the mass of the crystallization, see, percentage of the mass of water of crystallization can be obtained by subtracting the mass of this hydrated salt from this, so that we can have the percentage composition of each of them. Can have percentage composition. We said mass of water crystallization. Water crystallization. We can subtract from the one of the hydrated salt, mass of hydrated salt minus mass of anhydrous. We are also given that the mass of hydrated salt is given as 7.2 minus what we got here is 2.65. So here we're going to have 7.2 minus 2.65. So mass of hydrated is given as 4.55. the mass of hydrated is giving us 5.5. It's giving us. So what is the percentage? What is the percentage of water crystallization? What is the percentage of water crystallization? If we should have this now, I'm going to have a 4.55 times. So we're going to have the percentage. Let's wipe this. The percentage of water crystallization. So we have obtained that this is the mass of water crystallization. I'm going to multiply it times the total hydrated salt. We're going to have 4.55 times 100 all over the total hydrated salt, the mass of the total hydrated salt. So if you are going to have this, you're going to have a 4.55 times 100. You're going to have equals to 455 all over 7.2 divided by 7.2 divided by 7.2. That is equals to 63.2%. So the percentage of water crystallization is giving us 63.2%. So I will try and use a different method so that we can actually have how to solve this first step using mole ratio. We say we have 3 important equations when discussing mole ratio mole concept. We said when we can identify or we can calculate for the mole ratio of a substance in aqueous solution. So we can use that in a very simple way. So we're going to solve separately. Let's have a different method of solving this. Since the parameter is already given to us, we can actually have a more detailed solving as well. So the water crystallization, we said a hydrated, let's just get the parameter here. Hydrated mass conc is giving us 7.2 gram per dm cube. One, we are asked to look for the number of moles. The number of moles of acid to what? To the triazocarbonate 4, and we are asked to look for the concentration of a hydrous salt, concentration of an hydrous salt as well, and percentage of crystallization. So let's use a different method to solve all of this. As I've said before, we said we have 3 important equations when discussing mole concept, and we said the 3 equation is very important. We say number of mole is giving gram all over molar mass. So we can also solve the number of moles as well. Number of moles is equals to number of particles all over Avogadro's constant, 0.2 times 10 raised to the power 23. We also have that we can look for the number of moles of a substance in aqueous solution. We said molarity times volume all over 1000. So we're going to use this equation to solve for the mole ratio of each of these acid and that of the base. Since the concentration is given to us, the volume is given to us, we can actually use this equation, not this. So in this now, we're going to talk about the mole ratio. We're going to talk about the mole ratio of the acid. The mole ratio of acid. So by so doing, we say number of moles is equals to molarity times volume. Let's just have volume. Let's have is in DMQ so that we can actually have a direct conversion. So molarity of the acid is given to us to be 0.05, 0.025 times volume. The volume we use is 23.20, which is your titer value. As I've said before, the titer value is peculiar to a student. Or 23 divided by 1000 so that we can convert to DM cube. Here we have 0.0232. So times 0.050, we're going to have here we have 0.00116. This is the mole ratio of A. We have gotten the mole ratio of A. We can look for the mole ratio of B as well, so that we can just divide and move on. So here, this is 2. This is 2. We are going to have, that is 1, 2. The mole ratio of B, which is triazocarbonate 4. So we're going to have we said number of moles as well. Number of moles equals to molarity times volume in dm cube. That is to say, the molarity of the base is given as 0.025, yeah, times volume is 25. 25 divided by 1000. Let's convert to dm cube. 25 divided by 1000. We're going to have 0.025. So that is to say, 0.025 times 0.025 as well, we are going to have 0.000625. This is the mole ratio of B. So the mole ratio of A to triazocarbonate will now be, we divide this value by this. We're going to have 0.00116 divided by 0.000625. That is to say 0.00116 divided by 0.000625. We're going to have, we got 1.9 as well. So approximately we have the mole ratio of 2. Mole ratio of 2 as well. It's a very direct one as well. So that is the mole ratio. So the mole ratio of the base, if I should divide mole ratio of base by mole ratio, the mole ratio of B, as well, we are going to divide 0.000625 divided by 0.000625. It's going to give us 1. So the mole ratio of the acid to base is 2:1, as I've said before. So this is a different method for you to solve using the mole concept. So from there, if you're able to have this, you can actually impute that. If you're looking for the mass, the mass concentration of the hydrated salt as well, the mass concentration of the a hydrous salt is direct as well. You can actually say the molarity is given as 0. of hydrated salt 0.025 as said before times the molar mass 106. From there, you can actually move on. So there is only the mole ratio that I can actually have a different method to solve, so that you have different perspective on how to approach these questions. Thank you for watching. And throughout this, we have series of questions that will come your way. Please do wait to subscribe to this channel. As you prepare for your chemistry practical 3, make sure you are familiar and very sound in this aspect of calculation, because these questions are very, very straightforward when we are titrating a very strong acid and a weak base. So in this aspect, you must use a meta-arrange. So the questions you are going to encounter during your exam is being formulated in this format. Please pay very good attention to these calculations as we are coming on from now till tomorrow Saturday. I'll be uploading different perspective of this question, that the question may actually take such direction. Thank you for watching as you subscribe to this channel. Thank you.